Isn't that fun?
First of all, I want to welcome you to DEF CON 10. If you don't know, you're on the NetRecon and IDS track. Okay, I did that part. My name is Ofir Arkin. I'm the founder of the Security Group. I'm here to talk about XProbe 2. Last year I've been talking about XProbe 1 and OS fingerprinting 2. This year we're releasing the second version. I'm here to show you the tool, explain to you what the tool does, and show you other cool stuff. So we're gonna speak about some release information. Of course, everybody wants to get the white paper on the tool, history of the tool, problems with strict signature matching OS fingerprinting tools, the needs for a better OS fingerprinting tool, our approach, or the way that we call it, our fuzzy approach with operating system fingerprinting, the practical implementation, the country that I picked to demo on, and the questions. Something about myself, as I said before, I'm the founder of the Security Group. I do some security-related research, and on my regular job, I'm a computer security architect. Just to pay tribute to the guy who couldn't be here and actually is a part of XProbe and XProbe 2, Fyodor. This is actually a different Fyodor from the Fyodor that you know from Nmap. This guy actually lives in Taiwan. He's on the Snort developers and Snort mailing list. So this is the Fyodor that I'm dealing with. Today, and actually it's already on my website, a paper called XProbe 2, a fuzzy approach to remote active operating system fingerprinting has been released, as well as the beta/alpha version of XProbe 2. Just one remark, if you're using Linux, you must use VPCAP 071 in order to run this. We had some weird problems with VPCAP 04, so if you want to avoid these, use VPCAP 071. Tools available basically from sysdensecurity.com, xprobe.org, and xprobe.2.org. Just forward to that website. So as I said before, the first version of XProbe was released last year at the Black Hat briefings in August 2001, which is based on my research about the ICMP usage and scanning, which is also from our website. The tool places an alternative to other remote active operating system fingerprinting tools that rely heavily on the usage of TCP to do their job. If you didn't know this before, they are not able to differentiate between certain groups of Microsoft operating systems because the TCP stack on these are really similar or even the same. I can name, for example, Microsoft Me 2000 and XP, which share a lot of similarities on their TCP stack, and on the other hand, all the Windows NT4, 98, 98SC, and 95, which is another group of operating system, we share TCP similarities. The first versions of XProbe combine some of the methods that I've discovered in my research into a very simple, fast, efficient, and a powerful way to detect the target host underlying operating system. One of the problems of that tool was that it uses only ICMP related operating system fingerprinting tests, and it was not available for people who wanted to integrate other tests into that tool. They couldn't do that. One of the major drawbacks of the tool was that we didn't introduce a signature database, and basically we relayed upon a static decision tree to produce our signatures. That actually limited the way that the tool works, limited our ability to introduce more fingerprints, and it made it really hard to introduce new fingerprints into the tool. Although its disadvantages, the techniques used by XProbe 1 were adopted by a lot of commercial-based tools, and if you're going to download XProbe 1, which the current published version is 002, and the unpublished one is 002P1, you will see that it works. In most cases, you'll get good results and very accurate results. So just to give you a reminder of what I did last year, one of the sites that I visited last year, my stroll through the Chinese cyberspace in my first annual Chinese cybersecurity survey, was the Ministry of Foreign Affairs of the People's Republic of China. And that was actually running, at the time, Windows 2000. Unfortunately, when I tried to do the second annual Chinese cybersecurity survey, I found out that this site is already firewalled and everything is nearly blocked. But just to show you as an example what was here last year. So we basically look at our disadvantages. We kind of understood where the tool is being limited, and we wanted to integrate signature support to XProbe. But before doing that, as the usual tools that are available today, we did some analysis and we came into the conclusion that those tools suffers from several design flaws and accuracy problems. First of all, because of the condition that the tool operates against and the nature of how the strict signature matching is being done. This talk will be concentrating on how we aggregated different remote active operating system fingerprinting methods to identify a remote OS with high precision using our fuzzy approach to OS fingerprinting. Now, we'll start, first of all, what we'll do is we'll start talking about what we have today and the different tools that you are using. Tools like Nmap and Quasar. I don't believe that anybody is using Quasar these times, but more like Nmap and other derivatives. And then we'll see what we can enhance or what we want to do better, and then I'll show you what we've done with the tool. So all of these tools that are basically available out there today, they use some kind of a signature database to perform remote operating system recognition, and of course they're using strict signature matching and a fixed number of fingerprinting tests. That in order to identify the remote machine, the target operating system. This method is not perfect. It's affected from several issues. First of all, the topology of the system network that we're scanning, the nature of fingerprinting itself. These two major issues lead us to actually guess the type of operating system rather than accurately understand what we are operating against. If we look at the packet way, we can look at several obstacles that the packet might go through when we send a packet towards a target system and we don't really know what is going on. So on the way to the target, the packet might be affected by several different ways. First of all, several fields within that packet might be changed by a networking device or by a filtering device for the following reasons. For example, if we have a packet shaping device on our network, that packet shaping device might go look at several fields and decide, I need to do some work on those fields and we'll change the values that we've put in those fields. That might be inbound and that might be also outbound. We can name, for example, type of service values or quality of service values is a good example. Another issue is that routers or firewalls might spoof some responses for a targeted system they protect. If you know, Checkpoint Firewall 1 is able to send ICMP echo replies from system it is defending, or even initiate the three-way TCP handshake with an initiating system, and only when the TCP three-way handshake is finished, only then he will forward the information to the targeted system, which is protected by the firewall. And of course, if you are using, or if your target network is using a scrubber, that scrubber will basically go through several fields within the IP header and the application that you are using. Basically, scrub those to use certain types of values that it was decided before to use. So if you are relying on those, you will not be able to fingerprint the target operating system. So that family of problems, using a scrubber, using a packet shaping device, filtering firewalls, or filtering devices that are very smart, will potentially affect your fingerprinting. It will affect your results. Basically, you'll get false results or inaccurate results if you're relying on that ability. Now, if your fingerprinting tool relies on those particular fields which were changed by the either filtering device, scrubber, packet shaping, or other devices like this, you will fail. Sometimes we can remedy this thing if we will try to put some appropriate signatures into our database with the signature that will match the situation. But sometimes those devices are dynamic in nature, and for example, a scrubber might have different values introduced, or it basically depends on the site that it works on, and you will not be able to guess all the things that someone might do to you. Potentially doing that, we might even be able to recognize some type of packet filtering device, for example, OpenBSD NAT or Linux IP masquerading. But if we were going to try to do that, and the current strict signature matching abilities will fail, and probably will not get that accurate results. Usually we're relying also on several types of messages to be answered by target host in order to produce our fingerprinting. One of the things that we have is sending, for example, a SYN packet, a TCP SYN packet to a host, to a high port, and want that we will get TCP ACK or SYN ACK or a reset, depends on what we're getting. Usually we'll try to get the reset back, so it will be an indication that that host is up and running. But if you are being firewalling your system correctly, then if we're relying on that particular test, of course we will fail. If a tool that is able to do remote active operating system fingerprinting relies on this type of packets, and those were dropped by a firewall, everything will fail. Another major issue is using a load balancing in the way to the target. If there is a load balancing device in the way to the target, that load balancing device might send us to different web servers. We might hit different web servers and not initially our official target. So we'll get different results, different tests if those web servers are operating on different machines and not the same operating system. Some characteristics of the TCP/IP stack might be altered by a user. I can name, for example, the cctl command on the voice BSDs, the NDD on Solaris, and etc. There are also a number of kernel patches that are open sourced, like the IP personality patch for Linux kernels, that will alter the behavior of the TCP stack of your system. If again, a remote active operating system fingerprinting tool rely on getting some answers to and looking at those particular fields that were altered by those tools or by those tunable kernel parameters, our strict signature matching will fail. Also, if the remote active operating system fingerprinting tool that we're using would rely on malformed packets to produce its results. Those malformed packets will be able to be detected by a network intrusion detection system if it's properly configured. If one does not want to utilize malformed packets in order to produce its fingerprinting, and basically he wants to avoid the detection by the network intrusion detection system, most of the tools that are out there today will not give him the opportunity not to use these tests, or even if he wants to use those malformed packets, some of the firewalls out there are able to actually examine different IP header fields and decide that they want to drop the packets because they are not legal. I can name, for example, Sidewinder. I believe Secure Computing do that product. That basically that firewall you can play with every IP header you want, and you can decide if you want to drop packets according to things like that. If your tool relies on sending malformed packets, and there is an intelligence device on the way to the target, those packets getting dropped, you will not get any results. Questions? Somebody has any question until now? No? Okay. So, a lot of problems that actually results in bad fingerprinting, or even with the total loss of whatever you did or whatever efforts you put into scanning. Most, or the leading remote active operating system fingerprinting today use those kind of methods, and all of them produce fail and inaccurate results when you test them against more hardened topologies, or actually networks that people understand what they're doing. So with all those problems, what we want to have with a remote active operating system fingerprinting tool. Well, first of all, we want to have precision. Even if some particular test will fail or render ineffective, we want to still have the ability to fingerprint the targeted OS. We also want to have the ability to identify networking obstacles, such as filtering devices and load balancers. We also want to detect, or have the ability to detect modification to the OS kernel, and of course to detect scrubber activities. We want also to have the ability to limit the number of possible guesses to a finite number. Sometimes you don't get a definite answer, and you want to examine yourself the results. Sometimes you know which system you operate against. For example, if you are targeting a web server, you know that that web server is not operated under Windows XP. It would be most likely that it will be running under Windows 2000 server. So although the two stacks are similar, you know that this is a Windows 2000 rather than a Windows XP, for example. Now, there are other people in this world that might detect OS fingerprinting test, or their own way of doing OS fingerprinting. So we want to have the ability to give them to integrate their test into a tool. We want to have some kind of API for a tool, so other people with other brilliant ideas will have the ability to use the tool, introduce their own modus into the tools, still use the original signatures for the tools, but introduce their own into the tool as well. We want to have the complete control on which models we are using. So if we don't want to use any malformed packets, if we don't want to be detected, or we want to use whatever values to any IP headers, we want to have that. So when designing XProbe 2, we were looking at those issues, we were looking at those problems, we were looking at those needs, and we attempted to resolve most of these issues. We went back to basics, and we went to mathematics. We went to look for several mathematical approaches to fuzzy matching. We were looking at the Fisher discriminant function analysis. I'm not going to go through this. Also our recognition, matrix-based fingerprints matching based on statistical calculation of scores. and other mathematical algorithms. Yes, we went to math and we tried to utilize math in order to find a solution to these problems. We decided to go with a simple matrix representation of the scan or scans and the calculation of matches by simply summing up the scores for each test. All tests are independent of each other and each test is not affecting each other. This is basically the two-dimensional matrix that we're using with XProbe 2. First of all, you can see that this vertical vector is the operating system names. Basically, when we are running the tool is looking at the XProbe2.conf file, which holds up the fingerprinting database. It looks for the fingerprint and OSID entries. It reads them to remember how many entries it has, and according to that, it initializes that vector. The second thing that we're doing is once the test itself is being produced and we get the results back, we are scoring each and every OS according to the match it produces against its fingerprint. Now we have the ability not only to say, yes, no, we have actually some kind of a range we can assign to that score. We'll talk about it in 1 second. Now, when we finish all of our tests, at the end of our run, what we do is we sum up all of the columns that we have here. We sum up all of the columns, and what we're doing actually, what is the highest score on the totals line will be the most probable to be our targeted operating system. Is this understood? Should I explain this again? Everything is... yes? Yeah. Here's the answer. Today, with our alpha code, we're using 4 different values for the score. In the future, we're going to have the scale from 0 to 9 for the score. Today, we're having 0 to 3. Basically, yes, which is a perfect match, get 3, probably yes, get 2, probably no 1, and no 0. Each module for the fingerprints assign its own scores according to the take that the module creator has on the method he is using. So basically, if you come up tomorrow and say, well, I used the API in order to produce some kind of new remote active operating system fingerprinting test, what you have to do is just use our API and you are hooked up and you're working. So you can have your own take on that and you can assign whatever scores you like. Now this take gives us probabilistic support since the highest score given for the OS or even OSs is the most likely to produce an accurate match. So we can come and say that this and that percentage is that and that OS, and the other percentage is this and that OSs. Now we can go even and say that the other matches that we are having, or we can show the other matches that we're getting, in order to say, well, it might be a slightly different TCP/IP stack that we're seeing here. We might detect some kind of intermediate device that alters some values in the way to the target, or even identify some modifications. As I said before, the tool comes with a full API. You can go and read the documentation for the tool and see how you can hook up your own tests with the tool. This also means that although the tool currently using the basic test that we had for XProbe 2 plus 2 reachability models, we are still able to use whatever protocol and whatever test we want for OS fingerprinting. This means that in the future we'll see that we are going to add TCP models to the tool and basically create one tool that will be able to do whatever you want with OS fingerprinting. This approach overcomes failures with tests because we don't care if the test fails or not. Because if a test will fail, this means that the same score will be given to all the OSs. So if one test fails in the number of the test that we're using, that's fine. All of the OSs will get the same score. It will not affect our judgment. One can also use no for a test failed, or probably no if the signature is unknown and things like that. This gives one the ability to have probabilistic support for whatever model he is introducing. If you're using more tests, it suggests that you might have a better overall result with your fingerprinting. But sometimes, if you understand what you're doing, and if some test or some model is conclusive, you can assign it in the future more weight. Today, all the tests actually gets the same weight as the other tests, but in the future what we're planning to do is like having more conclusive tests have more weight upon other tests and give you the ability to be more conclusive when you know that actually tests are better be producing results for you. Well, we talked about this. With the tool, you have the ability to do whatever you want with, in order to send and receive things. You have the full control and flexibility. You can introduce whatever you want with it. The big obstacle of such a tool is dealing with yes-no tests, and I think it's one of the biggest obstacles of any fingerprinting test. A yes-no test is basically a test where we send some kind of a query packet and we wait to see if we get a yes or no answer. Yes or no answer, basically if we receive or not receive an answer for our test. If the target is being filtered, or the target or a tunable parameter on that target is actually configured not to answer that particular test, we'll never know that in our way it will produce a match or not. Using our approach to use our fuzzy approach, we actually limit that effect. What we're doing is actually saying that we have a number of assigned numbers or assigned values we can assign to the score. And on those yes-no tests, we can limit the effect of those tests on the final score. What we're doing is, instead of assigning a definitely yes or a definitely no score, we will assign a probably yes and a probably no score. So the range of scores that we are going to assign, if the test fails or not, is actually not that wider. So this approach will have the ability to not affect the final score so much, and still we are able to use those tests in order to put less weight on the final score that we are having. Questions until this point? Someone? No. When you're doing remote active operating system fingerprinting, it is very important to understand, or try to understand, what is the terrain that you are working against. What is the topology that you are working against? Sometimes people take the tools that are there, install them on their box, and then fire them away and just say, oh, I trust those results. That's a very good thing to do. I'm giving here two examples. I'll let you read the first example, but the second example is even more funnier. HP printers, for example. When you try to fingerprint HP printers, they are not identified by their model number. So this means that LaserJet 4 is not being identified because it's a LaserJet 4, or LaserJet 4100 is not identified because it's 4100. This is actually being done looking at the EEPROM and ROM that all those printers have. So if you're using Nmap, for example, and Nmap is going to tell you, oh, this is LaserJet 4. Yeah, right. So you can take all the HP fingerprinting stuff with Nmap and can delete them now. This is not a major issue, just to prove that untrusted fingerprinting databases can actually cause you more grief and more trouble. If the fingerprinting that are introduced inside those databases are not accurate, are not being verified, basically giving you false results, even if the test is having brilliant test conditions. So, XProbe 2, basically primarily implemented around the test that were introduced with XProbe 1. 5 different ICP-based fingerprinting tests plus 2 reachability tests. If you want to read on how those tests work exactly, you can go and read remote ICP bus doors fingerprinting techniques that I wrote along with Fyodor, which is available from my website. What I'm going to show you now, before I show you the other demos that I took last night against a nice country that I like, is a sample run that I've produced using Linux kernel 2.4.18, running XProbe against a Windows XP Professional on the same RAM. This is the sample run. I hope that everybody is able to see it. The Windows XP machine is 192.168.1.200. The tool actually initializes due to various reachability tests that I'm going to talk in a minute. Tells you how much modules were registered with the test. Here we can see there are 7. Runs the engine and tells you the guess probability of those 2 reachability tests. So if those 2 reachability tests were successfully executed, we can see that the guess probability is 100% for those 2 reachability tests. The other guess probability will be introduced for the other 5 modules that we have. So you can see here that the test run actually tells us that the primary guess is Windows 2000 host, but we can see that the same guess probability is also given to the Windows XP Professional machine. Now, I told you before that these 2 are sharing basically the same stack, so we got to the accurate answer. We're also showing a number of other guess probability results that might be in some way helpful to people, but you see here that we got the result that we were aiming to. The first reachability test is a simple ICP echo request, just to elicit ICP echo reply. The other reachability test is actually a time to leave distance test, which is actually a traceroute-like test. We're sending a TCP SYN packet to some port, and we're waiting to see if we get a TCP SYN-ACK or a TCP reset for our query. We're also looking to see if we get a reply at all. If we are not getting a reply, we will retransmit another TCP SYN packet to another port, and if that fails, we'll send a UDP datagram, hopefully eliciting ICP port unreachable. Those reachability tests has one common goal, to see if the host is up and running, to see if there is something to talk about with that host. The second model works like a traceroute-like thing, and eventually it will produce a list of nodes it's going through in order to get to the destination. In the future, we're planning to put actually some kind of a network map and actually illustrate you which hops you were going through and which hops you went through in order to reach your target. The other models that we have rely on the original XProbe architecture and tests. And of course, I told you that you can read all about them in the article. I don't want to get into that today. We simply don't have enough time. The OS fingerprinting that XProbe 2 returns is the most probable match. It's taken from a sum of all scores, and it reflects other possibilities as well, as it is shown here. And of course, we got the accurate results since Windows XP and Windows 2000 share the same stack of results. So before I go into the live demo or the demo I did last night until 3 a.m., is there any questions on the way this tool works? We want to ask any question. Yes? I can't hear you. Well, when we'll have an appropriate TCP module working, we'll do that as well. We want to integrate appropriate TCP tests and not those tests that basically you're puking on the network and just hoping that you get some kind of an answer. We're also hoping to use some kind of a more reliable TCP test that there are out there today. And of course, this is only an alpha code, working alpha code, to just show you guys what we're doing. So, yeah.
Last year you showed a logic tree where the results of the first test can determine what the second test is going to be, minimize the number of packets coming out. And what I'm seeing here is a list of tests that are run independent of the results coming back. Are there any plans to?
You can, we're going to put parameters that will allow you to control which test you want to run as well. So if you still want to use that approach, if you have, if you go and get our paper from last year's, you can use that approach as well. Sorry? Yeah. The problem with our previous year's tool, or the tool that's still available, is that if one of those, if the initial, if you're not getting a port unreachable, the test fails. What this tool gives you is the ability that all the tests will fail, except with one test, for example. If you're still being able to ping that host that you're against, you still will be able to tell, for example, that it's either Win2K or XP, for example. I was actually testing the tool yesterday against some interesting sites that, I can't tell you against exactly what I tested it, but it showed very accurate results, even if I just pinged the website. Any other questions? So, yeah. I didn't hear what you're saying. I didn't get your last part. If you can go ahead here and ask a question, I'll answer that.
If you have two packets, if you have two ICMP packets that go out for two different modules, have you considered caching the responses from the first one so that they don't have to send out the same packet again for the module that comes afterwards?
Very good question. Since this is only an alpha code, I didn't want to get on the nerves of Fyodor too much. So telling him that the first reachability test can actually be a fingerprinting test and actually saves us the need to send another echo request to that host. But with newer versions of the tool, this is exactly what we want to do. We want to chop off the first test or just do a reachability test, which is also a fingerprinting test, so which will limit the number of packets you need to send. We also will give you the ability to control exactly what you're sending. So if you say, I don't want to use the reachability test, you can use the other modules. And you can choose, and you will be able to choose whatever module you want to use exactly. So if you rely on one module instead of using three, or you say two modules are more than enough for me, it will give you that control. So if you are a more knowledgeable user, it will also give you more control on whatever tools and whatever methods to use with the tool in order to produce your same signatures and even same matching. Does that answer your question? So, as with last year, I just got myself a nice country that I like, and I decided that I want to fingerprinting some hosts there. This year, I made a story up as well, like last year, my stroll in China. When thinking of great, unbiased, accurate, cool broadcast service, I'm really thinking of only one, and for me, there is only one. If I want to get my news fast, reliably, I go to this website. The Islamic Republic of Iran Broadcasting. where they tell you exactly the truth about the world. I don't know who is worse, is this the Chinese or the Iranians, but it's not a discussion about this. So, having a simple run on the Iranian Broadcast Association, you can see that they're running Windows 2000. The way, or the reason they're not using Windows XP is that Windows XP is not running servers. So if you're getting guess probability 68% on both Windows 2000 and Windows XP, you can understand that this is Windows 2000 because we're targeting here a web server rather than targeting a host. This is the thing that IIS produces. You can see that this is IIS 5. You can see it's Windows 2000. So, if you're ready to stop the regime, which is all a big nice democracy if you didn't know, and you want to look for a nice, comfortable dungeon in a nearby jail near your parents' house, so you will be able to pay a visit if you're not that bruised. We go and look at Iran Yellow Pages. Well, unfortunately for them, Iran Yellow Pages is running on the Windows NT Service Pack 4 and above. You can see here that the probability guess is much higher than the other OSs due to the nature of the fingerprinting, and that's what we've been using. You can also see this is using IS4. You get the idea that this is Windows NT4. Now, since jail is really boring, and after some hours of torture, you need to relax. I was thinking of, more reading. Going to read the local newspapers. I don't know what frightens me more, but the jail or that picture of the man here. Look at his eyes. Well, again, Tehran Times is using Windows NT4 Service Pack 4 and above. This is actually a run that I've done with XProbe. We get the same result with the same fixed tree, and this time you can see that they don't block anything here, and the tree and the fixed tree with the original XProbe will still work. So after we got beaten up and we read some papers, it's about time to do some kind of out-of-cell activities. So we like to go and register to the Iranian Football Association. Unfortunately for them, again they're using Windows NT4. Maybe it's the same hosting facility, I don't know. And you can see here that this is IIS4, and this is NT4, SP4 and above. So after the regime gave you an organized vacation on one of their elite vacation sites, maybe you want to choose one for yourself. If you're really in that case and you want to have a holiday there, you can choose from a number of hotels courtesy of the government, of course bug-free. And they're actually running Windows 2000, which got the same probability guess as Windows XP. And they're running IS5, here you go, Windows 2000. I decided actually to give some red visit to some two nice sites that I liked from last year, and I bet that you'll appreciate that as well. One of them is the Wimbledon website, which is so nice, not to filter anything. Still running Windows 2000, still not a problem with fingerprinting. Here you go, this is IS5, very simple. But the site that I liked really much last year, of course, not including the Foreign Office of China, is the State Family Planning Commission of China. I paid a visit again to see if the policy was changed, if I go to China, if I can have more children. But no. A year passed, nothing has been changed in China, and the OSs haven't changed as well. So, still running Windows 2000. They didn't learn like the foreign ministry have learned. This is the interface I got. Okay, this is basically what's the demo. Next week, what I'm going to do when I go back home is to release a small text file telling you exactly how to produce your own fingerprints. On my website, the tool, the paper that accompany the tool, and I strongly suggest you read the paper. Don't go around the tool, send me an email saying the tool doesn't work. You need to understand what the tool does. If you understand what the tool does, understand what you can benefit from it. Also, I want to credit Bender Kidjariayev. Yeah, thanks God he's not here with me saying his name like this, which helped us with programming. I want to thank Captain Major for letting me on the Goo network last night. There's some further reading that you can do on the subject if you are interested. All available from my website. There is also a login article that I wrote that is not mentioned here that you can use. You can always send me questions or send me fingerprints if you want, and I'll integrate them and we'll answer your questions. This is basically it. Thank you for being here, and if you have questions, I'll be more than happy to answer.